Hello, and welcome back to my channel. In today's episode, we're exploring how the materials early humans encountered, like quartz, copper, iron, and salt, shaped minds by creating electromagnetic environments that interacted with our biology, influencing everything from cognition to group coordination. We'll look at how repeated exposure to these substances generated micro-adaptive feedback loops that laid the groundwork for ritual behavior and cultural structure. Modern science now confirms that these materials produce measurable effects on brainwave activity, cellular signaling, and coherence. So please check out the full bibliography in the channel bio if you want to dig into the sources that made this episode possible. These findings offer a scientific framework for behaviors early cultures would have encoded through ritual. Let's begin by taking a deeper look at this theory. Early hominins evolved in direct contact with naturally occurring materials that exhibited quantum and electromagnetic properties. These included crystalline materials, conductive metals, and ionic compounds found in soil, rock, and water sources. Interactions with these materials were unintentional, of course, but produced consistent physiological effects over time. Biological systems that aligned well with these materials' properties gained improved coherence and signaling capabilities. This led to subtle advantages in attention, coordination, and stress regulation. As these individuals reproduced, their traits became more widespread across generations. The connection between material exposure and evolutionary benefit occurred through environmental feedback loops. One of the earliest and most influential of these materials was iron. Iron deposits in the environment would have influenced magnetoreception, a trait that's still found in many species. Research suggests that human cryptochrome proteins may support magnetic field detection, particularly when coupled with environmental exposure to iron. Individuals who navigated terrain more efficiently or oriented with greater accuracy had a survival advantage. These traits could enhance foraging, group coordination, and migration under changing environmental conditions. Iron exposure may have acted as a passive selective pressure, reinforcing sensitivity to geomagnetic input. This magnetoreceptive sensitivity would later form a part of a broader orientation system in the human brain. Its interaction with conductive materials like copper may have further shaped neural responses. Quartz became another key influence during this phase. Quartz naturally emits piezoelectric energy when mechanically stressed. With quartz in early tool use or shelter building could have introduced low-frequency resonance field to the nervous system. These resonances interact with bioelectrical patterns in the brain, potentially stabilizing wave activity and improving focus. Individuals whose neural systems remain coherent in the presence of such fields likely had greater control over perception and memory. Piezoelectric interaction aligns with the concept of passive environmental entrainment. In areas with high quartz concentrations, this effect would have been reinforced across generations. Quartz exposure did not exist in isolation, but often occurred alongside metal-rich environments. One of the most conductive and biologically relevant of these was copper. Copper conducts electrical signals efficiently and plays an essential role in neural activity. Early humans who lived near or handled native copper deposits were exposed to small-scale electromagnetic fields. This exposure may have supported synaptic firing rates and network coordination through improved ion flow and biofield conductivity. Faster reaction times and better sensory processing would support learning, tool use, and social communication. Over time, exposure to conductive environments may have selected for more stable and responsive neural circuits. Copper's biological function overlaps with its environmental role, making it a conductive asset. These overlapping properties positioned copper as a dual reinforcement in human development. Salt introduced a third complementary mechanism. Salt, specifically sodium chloride, plays a central role in maintaining ionic gradients across cell membranes. Natural deposits of salt in the environment contributed to an external and internal ionic balance. Under certain conditions, salt crystals interact with ambient humidity and form localized ionic fields. These fields help regulate voltage gradients, reduce static interference, and improve signal clarity within the body. Populations with access to stable salt sources likely exhibited improved hydration, neural signaling, and thermoregulation. Salt's influence on electrolyte systems directly supports coherence at both cellular and systemic levels. When paired with conductive and resonant materials, like copper and quartz, salt amplifies biological stability. The three inputs, iron, quartz, and salt, created a multi-layered field of environmental selection pressures. Repeated exposure to materials with consistent electromagnetic and structural effects influenced early human behavior. Substances like gold, silver, salt, and obsidian produce measurable changes in brainwave regulation, ionic balance, and visual feedback. These materials were incorporated into communal settings and social practices due to their reliability in producing these effects. Over time, behavioral associations formed around their use, reinforcing both individual and group coherence. The feedback loop between material properties and behavioral outcomes contributed to the formation of structured rituals. Early societies began integrating these materials into tools, objects, and shared environments with increasing intentionality. Behavioral reinforcement encouraged long-term memory formation and cultural transmission. Among these materials, silver played a distinct role in local field modulation. Silver has the highest known electrical and thermal conductivity among elemental substances. Its surface properties reflect electromagnetic radiation while conducting bioelectric signals with minimal resistance. These characteristics would have modulated the immediate electromagnetic environment, particularly in situations involving attention, meditation, or visual focus. Studies suggest that field regulation near the body can influence cortical rhythms and sensory gating. The use of silver in objects worn or placed near the body may have supported these mechanisms through passive resonance. These effects, while very subtle, would have reinforced states of focus awareness and cognitive stability in predictable ways. Over time, silver came to be associated with cognitive boundary maintenance and information clarity, leading to its wider spread use. Gold exhibited a related but distinct function in low-frequency stabilization. Gold maintains structural and electrical integrity over long periods due to its resistance to oxidation and decay. Its ability to support stable low-frequency fields makes it useful in biological contexts where rhythm and coherence are important. When used in objects such as amulets, jewelry, or headpieces, gold may have contributed to field stabilization around the central nervous system. This would help regulate excessive function, reduce internal noise, and improve decision-making under stress. These attributes align with observed uses of gold in leadership roles, so all of Solomon's gold is what made him wise. Gold's function differs from silver by supporting rhythmic baseline regulation rather than reflective modulation. Together, their presence contributed to layered control over cognitive and environmental coherence. The next layer of field-level regulation across larger communal spaces we've already discussed a bit, but let's get into it a little more. Salt, composed of sodium and chloride ions, interacts with airborne moisture-charged particles to form localized conductive zones. These zones stabilize ionic gradients and reduce chaotic electromagnetic interference. In communal settings, salt would have supported consistent signaling among individuals by regulating field density and ambient charge. This may have improved verbal communication, behavioral synchronization, and overall social regulation. The placement of salt in structured environments reflects its role as a passive field stabilizer. Such effects scale across both individual and group levels, reinforcing ritual use and spatial orientation practices. Salt's environmental function complemented gold and silver by extending coherence across shared spaces. Obsidian provided an even more focused influence at the sensory-cognitive interface, of course, making it popular for later cultures' occult practices. Obsidian is a natural volcanic glass with a high density and a reflective surface, often used in tools and visual objects. When shaped and polished, it produces high-contrast reflections that stimulate neural pathways involved in self-regulation and spatial awareness. These reflections engage visual processing systems, reinforcing perception and accuracy and attention control. Obsidian's dense structure also supports energetic absorption, mimicking background interference during tasks requiring focus. Its presence in ritual objects and tools are likely served to enhance visual precision and internal alignment. That's why it's usually used as a scrying glass in the occult. This function is distinct from the conductive and field-regulating properties of metals and salts. So obsidian contributes to ritual coherence by anchoring sensory attention and reducing cognitive drift. These complementary effects laid the material foundations for structured consciousness in early societies, all without us even knowing what we were doing. Water's molecular dipole structure allows it to align with external electromagnetic fields, particularly in the extremely low frequency range. One example is the Schumann resonance, which naturally fluctuates around 7.83 Hz and has been shown to influence brainwave states. Water in natural settings such as springs, streams, and dew may have supported biological synchronization with these frequencies. This synchronization could have stabilized circadian rhythms and supported coherent states during sleep, meditation, or communal rest cycles. Repeated exposure to these conditions would reinforce internal timing mechanisms to regulate behavior patterns across groups. Water's capacity to support long-range coherence positions it as a biological interface with ambient fields. These effects occur through direct physical interaction with field-responsive molecular geometry. Other structures, such as those found in carbon lattices, contributed to coherence by supporting field stability at the structural level. Carbon-based materials like graphite and diamond exhibit highly ordered molecular arrangements that influence conductivity and stability. Diamond's rigidity and symmetry allows it to maintain internal coherence under a range of environmental conditions. Graphite, with its layer structure, supports charge mobility and resonant alignment along specific planes. These properties enable localized electromagnetic coherence, which may have supported stable neural signaling when these materials were present in living or working spaces. Emotional regulation, decision-making, and sensory clarity benefit from such consistent field environments. The structural presence of these materials can act as passive regulators of biological information flow. Their use in tools or ritual objects likely reinforce these effects over time. Organic materials with similar internal order further extended these interactions into nutritional and static field domains. Hexagonal organic compounds such as those in honey and amber influence biological systems through their symmetry and charge behavior as well. Honey contains structured sugars that support microbial regulation and metabolic efficiency. Amber holds electrostatic potential and has long retention time for surface charge, which can affect local electrical fields upon contact. These interactions can stimulate skin conductivity, nervous system response, and microbial balance. Their integration into ritual or medicinal practices would have produced direct and measurable effects on biological regulation. The consistent outcomes from using these materials reinforce their continued application in behavioral and healing contexts. Their functions are both biochemical and bioelectrical, bridging static field effects and metabolic coherence. Compounds found in psychoactive fungi expanded these effects into direct neural network modulation, the stoned ape theory. Psilocybin-containing mushrooms interact with serotonin receptors, particularly the 5-HT2A, altering perception, emotion, and connectivity. Functional MRI studies show increased communication between previously unconnected brain regions during psilocybin exposure. This network reconfiguration supports neuroplasticity, emotional flexibility, and rapid pattern recognition. In evolutionary terms, these effects may have enhanced learning, social bonding, and environmental awareness under controlled conditions. The temporary increase in neural complexity could support memory consolidation and behavioral innovation. When integrated into structured group settings, these compounds supported communal coherence and adaptive cognitive expansion. Their repeated use likely created selection pressures for tolerance and integrative processing. Bone-based materials provide another method for reinforcing internal coherence through mechanical and electrical feedback. Bone tissue itself is piezoelectric, producing an electrical charge when subjected to mechanical stress. Early humans used bone tools and experienced repeated mechanical interactions with these materials. These interactions may have influenced local charge fields near nerves, reinforcing signal strength and neural activation patterns. Piezoelectricity in bone also supports memory encoding through vibrational feedback during muscle movement and environmental engagement. These effects help to integrate sensory motor learning and long-term spatial mapping. Bone's role extended beyond structural support to include information reinforcement through mechanical electrical conversion. This positioned bone as both a physical and information medium in early cognitive development. Together with environmental materials, bone-based piezoelectric signaling helped establish the conditions for long-range biological coherence. Ancient environments were free from artificial electromagnetic interference, such as radio signals, power lines, or wireless transmission. Duh. This lack of high-frequency background noise allowed biological systems to operate under stable field conditions. In such settings, brainwave patterns, heart rhythms, and cellular signaling could align more easily with natural electromagnetic baselines. The Earth's low-frequency fields, such as the Schumann resonance, remained unobstructed and continuously accessible. These natural conditions supported baseline coherence in both individual and collective biological systems. Organisms with higher coherence in these low-noise settings experienced clearer signaling and more efficient psychological regulation. This contributed to behavioral coordination and perceptual accuracy. Shared environmental coherence helped facilitate group-level neural entrainment. In low-interference environments, group behaviors produce measurable synchronization in brain activity and physiological rhythms. Collective rituals aligned with lunar phases, solar events, or seasonal changes reinforce consistent behavioral patterns across participants. These events likely produce large-scale entrainment through coordinated movement, vocalization, or breath control. Studies in modern settings confirm that synchronized activity can lead to shared neural patterns and emotional states. Early societies would have reinforced these effects by repeating successful configurations across generations. Such group coherence improved communication, decision-making, and memory formation in shared social contexts. Repeated group synchronization events formed the social and neurological foundation of early cultures. That's why we see religion, religious artifacts, religious intention everywhere across ancient society. Structural environments further supported this coherence through material field modulation. Architectural structures made of stone or metal-bearing rock altered the ambient electromagnetic environment in predictable ways. Dense stone formations could block or reflect specific frequency bands, while mineral content within the structure could act as passive antennas. These features helped regulate the internal electromagnetic environment of spaces used for rituals, gatherings, or tombs. Not like the dead need environmental regulation, though. When individuals occupied such spaces, they experienced a modified field environment that reduced interference and supported coherent signaling. The environmental control contributed to enhanced concentration, memory, and coordination during ritual events. Ancient construction practices may have emerged from observations of these field effects and their influence on cognitive performance. Material selection and placement likely evolved in tandem with ritual structural design. Internal biochemical conditions, such as hydrogen sulfide signaling, added another layer of coherence control. Hydrogen sulfide is a gas produced naturally within the human body and plays a regulatory role in neural activity and metabolic efficiency. Its levels fluctuate based on activity, diet, and breathing patterns, many of which are modulated during ritual practices. Controlled breathing and fasting, common in traditional rituals, may have altered endogenous hydrogen sulfide production. Studies show that hydrogen sulfide influences neurotransmission, reduces inflammation, and enhances mitochondrial function. These effects support heightened focus, improved memory, and reduced cognitive fatigue. In structured settings, the modulation of gasotransmitters, such as hydrogen sulfide, may have reinforced cognitive stability and internal synchronization. The biochemical environment worked in parallel with external field regulations to maintain peak functional states. Ionic balance across neural networks further enhanced the system of internal coherence. Ionic clusters composed of sodium, potassium, calcium, and chloride regulate signal transmission and timing throughout the nervous system. In low interference environments, these clusters form stable configurations that support efficient and consistent signaling. Proper functioning of these ionic systems is essential for attention, memory consolidation, and executive control. High environmental noise can destabilize these systems, but ancient settings maintain the stability required for sustaining cognitive performance. This would have allowed early humans to access higher-order cognition under natural field conditions without artificial interference. The stability of ionic clusters contributed to the emergence of more complex thought, planning, and social organization. These conditions set the stage for selective reinforcement of neural traits aligned with coherence. Structured material use, ritual behavior, and natural environments together supported a coherent cognitive infrastructure. So, this all sounds super fantastical, but I'm definitely only talking about micro feedback loops. So these are small scale evolutionary changes that happen over great periods of time. One of the questions that arises when talking about this is, If these rituals would have worked to increase cognition and memory and focus back then, why don't we see greater effects of that now? Well, modern environments are saturated with artificial electromagnetic fields produced by wireless networks, mobile devices, power infrastructure, and digital equipment. These high-frequency fields introduce interference across biological signaling systems, disrupting baseline rhythms that previously aligned with natural electromagnetic cycles. Unlike the low-noise settings of our ancient environments, contemporary humans live with dense fields that fluctuate continuously and unpredictably. Studies in bioelectromagnetics indicate that persistent EM exposure affects circadian regulation, attention, and metabolic rhythms. This shift creates instability in systems that depend on regular, low-frequency input to function optimally. The increase in electromagnetic noise alters both the external signaling environment and the internal coherence of biological systems. Disruption of these patterns contributes to misalignment in neural, cellular, and behavioral processes. This effect is compounded by synthetic materials that degrade field consistency. Many synthetic materials used in modern architecture, clothing, and technology lack conductive or coherent properties of their natural counterparts. Plastics, treated fabrics, and processed materials often reflect or block electromagnetic fields in inconsistent ways, creating localized pockets of interference. These materials fail to support resonance or conductivity, which are critical for maintaining internal biological coherence. Artificial environments reduce the presence of naturally stabilizing materials such as quartz, copper, and salt, leading to increased physiological noise. This degrades the effectiveness of internal signaling systems responsible for cognition, focus, and coordination. Structures made from these materials do not support consistent field dynamics and may disrupt neural feedback systems. The absence of coherent material interaction raises the energy and time required to maintain stable internal states. As a result, modern rituals require different conditions to function effectively. Contemporary ritual practices face greater difficulty achieving coherence due to this increased background noise and decreased material resonance. Activities that once produced reliable internal alignment demand more controlled environments, extended preparation, and carefully selected tools. Materials used must compensate for the lack of passive environmental support by providing stronger or more targeted coherence feedback. Time of day, geomagnetic conditions, and environmental shielding have become more relevant variables in determining outcomes. These adjustments reflect a broader change in the interface between human biology and environment. Ancient rituals functioned under consistent external support. Modern rituals must actively recreate those conditions. This shift increases the cognitive load and reduces the accessibility of sustained coherent states. These effects are further amplified by cultural and psychological factors. Constant digital stimulation, fragmented attention, and algorithmically curated content reduce sustained focus and increase cognitive fragmentation. These distractions interfere with the brain's capacity to maintain rhythmic coherence across networks responsible for memory, intention, and sensory integration. Psychological fragmentation undermines the same internal synchronization mechanisms that rituals previously helped reinforce. Over time, this reduces the efficiency of adaptive learning, emotional regulation, and coordinated social behavior. A culture centered around continuous information input reduces the conditions necessary for deliberate coherence. Without behavioral and environmental alignment, biological systems struggle to maintain organized patterns of function. This cognitive shift introduces long-term changes in neural architecture and energy regulation. Biological systems under these conditions show measurable decline in coherence-based signaling. Decoherence in the body affects both immediate and physiological function and long-term cognitive development. Disruptive ionic cluster stability interferes with synaptic timing, muscle control, and organ regulation. Changes in electrical gradients alter the efficiency of cellular communication and immune function. Mitochondrial activity and neurotransmitter balance are also affected, reducing the energy available and the processing speed. Chronic exposure to field disruption correlates with symptoms such as fatigue, attention deficits, and mood instability. These outcomes reflect a systemic degradation in quantum coherent signaling at the cellular and network levels. Modern health conditions increasingly reflect this breakdown of internal coordination systems. Understanding the effects of decoherence sets the stage for examining how ancient materials may reintroduce stability through field-based interaction. Quantum biology provides a measurable framework for understanding how coherence affects living systems. Research by Jane Persinger and Lambert demonstrate that biological structures respond to low-frequency electromagnetic fields in ways that align with coherence theory. These studies confirm that molecules in cells exhibit phase-dependent behavior, meaning their function is influenced by field alignment over time. Biological rhythms such as heart rate variability, circadian cycles, and neural oscillations follow coherence principles under controlled conditions. Crystalline systems within the body, including microtubules and structured water, exhibit quantized responses to electromagnetic fields, supporting the presence of quantum-level interaction. These findings establish a clear mechanism for how early environmental exposure to structured fields produced lasting biological effects. The same principles apply to external materials historically used in ritual practice. Current studies confirm the physiological impact of metals and minerals once chosen for their consistent behavioral outcomes. Research on materials such as silver, gold, copper, quartz, and obsidian demonstrates quantifiable effects on human biology. Silver nanoparticles have antimicrobial and conductive enhancing properties, supporting immune regulation and biofield integrity. Colloidal gold has been shown to influence neural excitability and reduce inflammatory markers, especially in low doses. Copper deficiency is linked to impaired neurotransmission and weakened connective tissue function, underscoring copper's importance in maintaining systemic coherence. Quartz crystals continue to exhibit piezoelectric behavior that can modulate local electric fields under mechanical pressure. These studies validate historical uses of these materials in ritual, medicine, and architecture as biologically active rather than merely symbolic. Their consistent properties contribute to field regulation, network timing, and physiological balance. Similar findings have emerged in studies of salt and its influence on ionic stability. Ionic clusters, which are composed of charged particles, serve as the basis for cellular signaling and energy distribution. Research by Reiber and Bai confirms that these clusters have coherent quantum systems when environmental conditions are stable. Their structure influences membrane potential, neurotransmitter release, and intercellular transport across major biological systems. Salt acts as a medium for maintaining these clusters by regulating external charge density and osmotic balance. In controlled studies, ionic behavior is shown to change under different electromagnetic conditions, confirming that salt rituals could affect internal coherence. These observations link environmental ion availability to long-term cognitive and metabolic performance. When examined through this lens, even traditional salt-based purification practices align with field-stabilizing behavior. Hydrogen sulfide provides yet another example of material-coded regulatory mechanism. Hydrogen sulfide functions as a gasotransmitter in neuro and vascular systems, where it influences mitochondrial respiration and inflammatory response. Research led by Andres and colleagues show that hydrogen sulfide plays a key role in modulating neural coherence, particularly during stress or sensory overload. Controlled production of hydrogen sulfide has been observed during fasting, breathwork, and low oxygen rituals, correlating with improved attention, emotional regulation, and memory encoding. These biological effects match those described historically in ritual states, characterized by sensory clarity and endurance. This gas interacts with calcium and potassium ion channels, creating a network-wide shift in signaling dynamics. Such findings support the inclusion of hydrogen sulfide-based regulation in the broader model of quantum biology. Its role strengthens the link between ancient ritual practices and measurable field-based mechanisms. These insights are gradually influencing modern models of mind-body health. The concept of quantum coherence is increasingly integrated into fields such as functional medicine, neurofeedback, and psychophysiology. Practitioners now incorporate frequency-based therapies, structured materials, and breathing protocols designed to support phase alignment and biological signaling. Scientific literature supports the role of low-frequency stimulation, conductive materials, and ionic regulation in enhancing resilience and performance. These applications reflect a reintegration of ancient observational knowledge into evidence-based practice. By correlating environmental interaction with measurable biological response, modern science reframes ancient rituals as adaptive technologies. This shift enables new discussions around consciousness, health, and collective regulation grounded in testable models. As coherence theory gains interdisciplinary traction, the historical use of materials takes on renewed relevance. The scientific foundation provides the context for understanding their role in higher dimensional structures. Recent scientific findings are beginning to realign with principles long embedded in historical ritual practices. The properties of materials once chosen intuitively, like salt, gold, silver, and obsidian, now show measurable biological effects in laboratory conditions. This convergence between empirical data and ancient behavior reflects a renewed understanding of how environmental input shapes cognitive structure. The reintroduction of quantum coherence models into medicinal and psychological frameworks indicates a shift toward practical integration. As research confirms field-based regulation in human systems, older fragments once seen as cultural or symbolic are beginning to be reevaluated. The alignment between scientific outcomes and ancestral practices suggests continuity of knowledge through observation and environmental interaction. These practices were never isolated from biology, but functioned as regulatory tools. This recontextualization sets the stage for considering deliberate coherence as a tool for conscious development. Structured coherence practices have the potential to support selective neural activation, emotional regulation, and perception expansion. Quantum coherent environments created through material use, rhythmic timing, and field alignment can support adaptive neuroplasticity. When applied intentionally, these methods allow individuals to maintain high-functioning cognitive states for extended periods. Examples include consistent focus, integrated thinking, and memory retention under challenging conditions. Studies in neurofeedback and heart rate variability support these effects when coherence is maintained over time. As coherence-based practices became better understood, their role in shaping cognitive outcomes grows more relevant. The implications for educational systems, clinical treatments, and collective behavior are increasingly supported by data. These findings also raise the question of what capacities emerge when coherence is sustained at even higher thresholds. When biological systems remain in sustained coherent states, they exhibit patterns associated with advanced cognitive integration. These include improvements in sensory accuracy, precognitive awareness, and large-scale pattern recognition. Field stability at both cellular and network levels support nonlinear decision-making and increased error correction capacity. These outcomes correspond to what were historically called altered or expanded states of consciousness. Measurable shifts in functional connectivity support the idea that coherence may be linked to heightened human potential. Experimental settings using rhythmic simulation, targeted field exposure, and conductive material applications have demonstrated repeatable effects. These conditions suggest pathways towards selective cognitive enhancement and coordinated group outcomes. To explore these possibilities further, accessible tools for coherence maintenance are essential. Ritual materials provide passive support for coherence under modern environmental conditions. Conductive and resonant materials may buffer against noise, stabilizing signaling, or reinforce entrainment across neural systems. Structured environments designed with biological coherence in mind improve the likelihood of effective learning, social regulation, and emotional resilience. Incorporating these materials into wearable devices, architecture, and personal routines extends their function beyond ceremonial use. Their application can provide consistent support for systems operating under high stress or interference. This brings ritual material use into alignment with evidence-based preventative care and personal performance strategies. One example of this that we see in the medical community today are those copper magnetic bracelets that are used for arthritis prevention or arthritis pain management. So while their form might differ from historical models, their function remains tied to coherence preservation. Understanding this connection clarifies how rituals contributed to long-term adaptation and system optimization. Rituals provide structured environments in which biological, emotional, and social systems align through rhythm and material coherence. When repeated under consistent conditions, rituals reinforce signaling ability across multiple layers of human experience. These structures encourage internal feedback, reduce cognitive fragmentation, and maintain physiological regulation. Scientific frameworks now offer models to describe how coherence reinforces adaptive behavior and group resilience. Ritual behavior, previously seen as a cultural habit, or just for funsies, now appears as an applied strategy for navigating field-dependent systems. This supports the view of ritual as a catalyst for biological alignment and cognitive evolution. As coherence science advances, the evolutionary role of ritual becomes increasingly defined. These insights prepare the foundation for understanding how human systems interact with higher dimensional geometry. Ritual materials generate structured electromagnetic fields that support recursive quantum coherence. This coherence is characterized by sustained phase relationships that allow information to circulate through the system without degradation. Materials such as quartz, gold, and salt produce stable fields that reinforce this internal feedback, allowing biological signals to loop rather than dissipate. These loops maintain signal integrity through closed, energy-conserving pathways that amplify function with repetition. The process reflects a condition where energy and structure re-enter their own systems at different phases, reinforcing stability. Recursion within these materials mirrors patterns found in topological systems with higher-order geometry. The continuous loop formed by these interactions introduces a framework for interpreting biological structure through dimensional recursion. This framework is further clarified through the application of 4D geometric models. Material-generated fields display behavior consistent with the topology of a Klein bottle, a four-dimensional object with continuous inner and outer flow. In 3 dimensions, the Klein bottle appears to intersect itself, but in 4 dimensions, the structure forms a seamless loop. This non-orientable object has no distinct inside or outside and supports uninterrupted flow along a recursive path. Materials that sustain quantum coherence exhibit field behavior similar to these Klein bottle dynamics, where signals return with altered orientation but preserve phase. Biological systems operating within these fields can internalize continuous transformation without reflection loss. The geometry supports functions such as memory integration, signal compression, and topological invariance in biological systems. These properties allow feedback systems to reorganize without discontinuity, maintaining coherence during transition. When energy circulates within quantum coherence systems, it follows inward curving phase-aligned loops that do not require external input to complete. This pattern avoids decoherence by cycling through feedback paths that retain signal integrity. Klein bottle structures model this process, where returning energy is transformed rather than reversed. This loop allows information to persist in systems by folding space rather than extending it, creating a dimensional shortcut for energy and signaling. Materials used in ancient rituals maintain field environments capable of supporting this kind of recursive energy behavior. Their structural stability contributed to the internal preservation of energetic cycles across biological layers. The absence of loss or dissipation in these loops parallels how non-orientable surfaces distribute flow without reflection. These characteristics align with the concept of nonlinear quantum trajectories. In nonlinear quantum systems, energy and information don't follow straight or reflective paths, but instead propagate through curved and recursive vectors. This behavior enables consistent coherence over time by reintroducing signals through alternate phase entry points. Materials that support these dynamics act as stabilizers of nonlinear propagation, preventing interruption or scattering. This aligns with observations in structured environments where ritual materials influence attention, memory, and cognitive integration. Unlike linear systems that require constant correction, nonlinear pathways adapt through internal reorganization. These dynamics allow for self-regulating coherence, reducing entropy in signaling systems. Such environments promote higher stability and deeper integration of complex inputs. These properties suggest that certain materials function as bridges between dimensional structures. Structured materials capable of sustaining quantum coherence encode spatial behavior that reflects higher dimensional geometries. Their interaction with biological systems support phase retention, signal reentry, and field preservation, qualities found in non-Euclidean models such as the Klein bottle. When humans interact with these materials, their biological rhythms and neural structures adapt to the material's field constraints. This adaptation embeds recursive logic into cognition, enabling internal representations that reflect dimensional crossover. The feedback loop between environmental, material, and biology produces a coherent system aligned with higher dimensional interface dynamics. This process connects quantum material science with spatial models of cognition and evolution. Materials do not only act as a passive support, but function as active participants in spatial encoding. These properties define their role in mediating dimensional interaction through biological systems. Human physiology exhibits consistent responsiveness to quantum coherence across multiple biological systems. Studies in neurobiology, cardiology, and molecular dynamics confirm that phase-aligned signaling influences memory, attention, and cellular communication. These effects occur within electromagnetic ranges measurable in laboratory settings and align with natural field fluctuations. Coherence in these systems promotes energy efficiency, adaptive learning, and long-range regulation. The presence of quantum behavior in neural microtubules and ion channels suggests that biological function relies on coordinated quantum events. These findings support the view that human consciousness is a product of structured, quantum-responsive systems. Human perception, cognition, and memory are shaped by coherence across nested biological scales. This coherence responds to material inputs that define internal information architecture. The materials that we've talked about today influence biological coherence through these structured field effects. Their inclusion in early rituals created controlled electromagnetic environments that reinforce stable signaling patterns. This consistency supported the development of attention, social regulation, and symbolic thought. Over time, exposure to these materials shaped the sensory and neural architecture of human groups. Material effects aligned with environmental feedback to guide developmental plasticity toward greater coherence. The influence of materials extended beyond sensory interaction to systemic organization. These relationships formed the foundation of how coherence was embedded into conscious experience. Recursive interactions with structured fields led to a geometric encoding within biology itself. Human biological systems exhibit structural features that reflect recursive geometric logic. Folded neural tissues, looping vascular systems, and oscillatory rhythms demonstrate repeated internal alignment with circular and non-orientatable forms. The Klein-Bottle model offers a description of how recursive systems maintain continuity without linear expansions. In this model, feedback loops transform phase without creating reflection points, aligning with observations in brainwave dynamics and perception cycles. Coherence within this geometry sustains awareness across temporal and spatial shifts. These embedded structures allow human consciousness to maintain consistency across changing conditions. The mechanisms for this function is supported by material interactions that reinforce recursive behavior. Ritual materials generated quantum coherent fields that guided energy through structured phase-dependent routes. These routes reinforce topological features such as non-orientatability and feedback retention within human biology. The ability of materials to support 4D-compatible field behavior enabled consciousness to internalize higher dimensional logic. Recurring exposure to these conditions allowed recursive feedback structures to form during developmental stages. These structures aligned with dimensional models where time, space, and energy converge along continuous loops. Interaction with these fields created cognitive systems capable of encoding nonlinear logic into perception and memory. Dimensional integration through material exposure reinforced spatial awareness and recursive identity. These characteristics formed the interface between human biology and evolutionary development. Human consciousness evolved under environmental conditions shaped by quantum materials and recursive field interactions. This evolution favored systems capable of maintaining coherence in response to structured external input. Consciousness, as a pattern of stable yet adaptive feedback, developed around these consistent environmental features. Evolution reinforced traits that supported alignment with field-dependent signaling and recursive pattern recognition. Quantum material interactions acted as both boundary conditions and developmental scaffolds for this process. Biological systems optimized for coherence gained efficiency, flexibility, and adaptive capacity. This evolutionary trajectory suggests that material interaction played a critical role in shaping dimensional cognition. Human awareness reflects a stable configuration of quantum geometry shaped by recursive environmental feedback. Ritual materials demonstrate that human physiology operates through quantum coherence by providing stable electromagnetic environments. Their interaction with biological systems consistently influences brainwave activity, cellular signaling, and phase synchronization. These materials reinforce coherence through resonance, conductivity, and field regulation. The measurable biological outcomes support the idea that humans evolved to function within quantum coherent frameworks. This alignment suggests that quantum responsiveness is not incidental, but fundamental to human structure and behavior. Materials historically selected for ritual purposes continue to exhibit coherence-enhancing properties in modern research. Their consistent physiological effects support the argument for an intrinsic human relationship with quantum fields. This connection becomes clear when examining the recursive structures formed within these fields. These fields cycle energy through phase-aligned paths without loss, preserving information across space and time. The Klein-Bottle provides a model for how this energy circulates in 4 dimensions without creating discontinuity. This topological behavior supports the sustained coherence required for stable perception, memory integration, and adaptive response. When ritual materials are used in their specific arrangements, they reinforce this geometry through layered field interaction. Their properties guide energy through loops that continuously re-enter the system, supporting recursive cognition. The geometry becomes embedded in both physical structure and internal processing. These recursive fields form the dimensional structure needed for higher-order integration. Quantum coherence allows energy and information to move through recursive systems without fragmentation. Structured materials act as dimensional regulators by enabling feedback to return transformed but intact. This quality allows biological systems to access nonlinear information without distortion or reflection. The continuity preserved in these feedback loops mirrors behavior found in 4D spatial models. Materials enhance this behavior by providing the field conditions necessary for energy cycles. Quantum coherence allows energy and information to move through recursive systems without fragmentation. Structured materials act as dimensional regulators by enabling feedback to return transformed and intact. This quality allows biological systems to access nonlinear information without distortion or reflection, and the continuity preserved in these feedback loops mirrors the behavior found in 4D spatial models. Materials enhance this behavior by providing field conditions necessary for energy to cycle coherently. The result is a sustained interface between biological systems and topological structures. Human cognition organizes within this field interface as a function of recursive coherence. These processes become more apparent when viewed through the lens of ritual behavior as structural encoding. Ritual actions produce predictable psychological changes by aligning the body with coherent field environments. Over generations, this produced biological adaptations that embedded these microfeedback structures into physical and cognitive systems. The repetition of these rituals reinforced internal systems that reflected this recursive geometry and nonlinear signaling. Ancient rituals, therefore, functioned as practical tools for encoding higher dimensional logic into biological form. Material interaction provided the structure, while ritual behavior shaped the pattern of translation. This process defined how environmental coherence was internalized and retained. Dimensional translation occurred through structured engagement with recursive field environments, and so these interactions contributed to the biological encoding of quantum geometric function. And human evolution progressed through sustained interaction with materials capable of supporting quantum coherence. These interactions facilitated the development of recursive biological systems capable of interpreting and maintaining dimensional structure. The materials used in ritual did not serve symbolic roles alone. They actively supported phase alignment and cognitive stability. Their contribution to feedback regulation shaped the evolutionary direction of human consciousness. This framework positions human awareness within a 4D hyperuniverse defined by coherence, recursion, and topological interaction. Material engagement provided both the input and structure for this interface to develop. The outcome is a model of evolution grounded in feedback-based geometry. Human consciousness, shaped by material influence, reflects a biologically stabilized interface with higher dimensional space. Well, and that's all for today. I hope you enjoyed this episode on 4D quantum consciousness and human evolution of ancient ritual. Don't forget to like and subscribe like the winners that you are, and I will see you in the next one. Bye!